Hi, today I want to continue the series for the nRF51822 from Nordic Semiconductor and how to implement a Bluetooth low energy service. And as an example with the MAX6675, a K-type thermocouple to digital converter. Now let's repeat some overview about the hardware architecture from the nRF51822. First, we have our hardware. It's based on a ARM Cortex-0, and on this we have the ARM Cortex microcontroller software interface standard CMSIS, and then we have two blocks, the nRF5 API or the SDK, in example the version 12, and on the other side we have our soft device. It's a black box for us from Nordic, but we can use it with the nRF5 API, and on top we program our own application or our own firmware. Now let's go a little bit deeper. On the nRF5 API we have our peer manager who keeps track on all the connection to our Bluetooth low energy device and the flash data storage that stores the connections, and we have also the Bluetooth advertising parameters and connection parameters in the API, and with the soft device we communicate over the soft device functions, and we call the Bluetooth stack in our soft device with the generic access profile or GAP, and the generic attribute profile or GAT, and the generic attribute profile server or GATS, and the soft device also keep track of all the events with the event manager and also the power management. And in our firmware we have to handle all the sensor data in combination with all the Bluetooth handling. Let's continue with the code blocks. We first configure and initialize the soft device with the soft device enable functions. Then we register our Bluetooth low energy handler with the soft device handler settings. Then we configure and initialize the peer manager since SDK number 12 with the PM functions. Then we register the manager handler with PM register, and also we register the flash data storage handler. Then inside the soft device we configure and initialize the generic access profile with the SD, BLE, GAP functions. Now we came to the block with our own to-dos. We first set our universal unique identifier or UUID. We can choose a 128-bit own ID, or we use a standard 16-bit UUID given by the Bluetooth Special Interest Group or SIG. Then we add the service declaration to the attribute table of our generic attribute profile server and add one or more characteristics to the attribute table. The next steps are to configure and initialize the advertising profile, configure and initialize the connect parameters, start the advertising, and do an endless loop with the event handling and power management from the soft device. After our Bluetooth service is running, the soft device sends out Bluetooth low energy events, and we have to process the events with the connection events, the peer management for Bluetooth low energy events, the advertising events, and also the generic Bluetooth low energy events. Next step is to process our own sensor Bluetooth low energy events, and also the soft device can send some system events for the flash data storage handling and also the Bluetooth system advertising events. In our code for the Bluetooth event handling, we call the Bluetooth connection state module event handler. Then we call the peer manager event handler. And inside this, it's called the identity manager, the security manager, and also the gets cache manager. And then we handle the connect parameter events and also the Bluetooth advertising events. Now we can handle some special advertising events and also the events from the peer manager. Then we have to handle all the Bluetooth stack events, and now for our own parts we can handle the own Bluetooth events. Now to our example, if for instance the soft device sends a Bluetooth event for connection and also receive an event to notify the sensor data, then we can start a timer, or if we get an event for disconnection or stopping the notification, then we stop the timer. Now let's have a look at the timer event handling. On every timeout of our timer, we collect the sensor data and send them out via Bluetooth and our Bluetooth update function, and this set the values of our Bluetooth attribute table, and we send out the notification by setting the HVX parameter structure. Now let's go to the code overview. If we receive a gets write event and the Bluetooth notification enabled is true, then we send out our own notification enabled message and start the timer. And if we receive a gets write event and the notification enabled is false, then we send out a disabled notification message and stop the timer. Or if we receive a gap disconnect event, then we also send out a disconnect message and stop the timer. Now we have a look at the timeout events. For the first event, we prepare the sensor reading, then we read the temperature sensor data and start the update over Bluetooth, and we set the value and send out the notification attribute with the soft device commands. Now let's do a code walkthrough. We first inspect our main file, and we have all the include files, the header files. Then we have all our defines. We have no central device, but we have one peripheral link. Our device name is defined. Then we set our advertising interval and the timeout. Then we set our timer pre-scaling and how many timers we need. Then some connection intervals. Then we set some secure parameter for Bluetooth low energy and some error handling. Then we set our timer intervals and the timer definitions. Then some initializing commands for our SPI communication. Then we can have a look at the main function. The main function, we initialize our sensor data and SPI configuration and the timers. We only create a timer, but we don't start the timer yet. Timer started later. As I mentioned earlier, the timer is started by the Bluetooth events. Then we initialize the Bluetooth stack, and with the soft device enable commands as mentioned. Then we set the Bluetooth handlers and the system handlers. Then we initialized and configured the peer manager with the PM commands, and we register the peer manager handler and also the flash data storage handler. Then next we initialized gap. We set our device name and our appearance and set all the gap parameter. Then we initialized our own service with our own handlers. Then we configure and initialize the advertising and set our profile and our services. Then we configure and initialize the connect parameters. And then we start the advertising with the soft device. Then we go to the endless loop and to power manage. And all we do is set the soft device to event handling. So now we can go to the event handling. The event handling is first set in the Bluetooth stack. So we have a look at the event dispatcher. We receive the connection state events, then the peer manager events, then the connection parameter events, then the advertising events. Then we handle all our own events for connecting and disconnecting and timeout and so on. And then we process all our own events, like a connection, a disconnection, or a write event. And also we have here the advertising events. We have set in our initializing of our advertising here on advertising events. Then we, in our peer manager init, we have set the peer manager event handler. And there we also handle all the peer manager events and also the file data storage events. So after all, we're looking about the events. We have a look at the timer. So the timer started if we receive a Bluetooth event. So we have a look at the event dispatcher, and therefore we call our own event handler, and our own handler is set in our services init. So we have here our event write handler. So the soft device calls the Bluetooth event dispatcher, then it calls our own event dispatcher, and this calls the on write event, and then it's called our own event handler, and this is set in our services ini there. So we receive the write, then we call our own event handler, and this is this routine. And this routine starts the timer if there's a notification enabled event, and all other events stop the timer. And then we have a look at the timeout handler for our timer. At the timer init, and the timer init set the timeout handler, and the timeout handler first prepare the reading for our MAX6675 and then reads the Celsius data. And then do an update, and the update calls the Bluetooth temperature update. The temperature update set the gets value and then send out the gets HVX notification. We can have a look at the SDK configuration. We have to enable the Bluetooth advertising, and also we have to enable the peer manager. Then we have to enable the clock for the timer. Then also we have to enable SPI communication. Here we have SPI instance 0 enabled. Now let's have a look at the make file. Just set some defines. Our custom board is used. Then we use a nRF51822 chip. We enable our logging via UUID. The soft device is present. I use the soft device 130. Then we include all object that's needed for Bluetooth. And that's it. And now we can clean our configuration and do a build. So 4.5 seconds, we compiled our firmware. Now, if our program is ready to flash, let's look into the flash process. And we can assume that our chip is filled with random data. So first step is to erase all the flash memory onto the nRF51822. And then we second flash the soft device. And after the soft device, we flash our firmware or application with our Bluetooth low energy service. I use the make file to flash all the soft device and the application to the nRF51822. But before we begin, let's open PuTTY to display all the logging information. And if our terminal is ready, then we can use our make target. I use the S130 soft device, so I do this make target, and this also flash our firmware. And after this, the flashing do a reset, and then we can see the output messages on PuTTY. Now let's look at our bench and our sensor with our mobile device. We open the nRF Connect application from Nordic. and scan for our Bluetooth low energy service. Now we can have a look at the connection a little bit. And now let's connect to our service. And we can discover some generic access data. And some generic attributes, but there's nothing declared. And there's our unknown service with our 128-bit UUID. We can discover the notification message. It's now off. So let's switch to on. And now our device is transmitting the temperature data. And we can have a look into the log information. But it's clear that the 2-byte hex data is our temperature sensor data. Now let's switch notification off and again on. And now the data is transmitted again. So we can disconnect to our service and close the application. Now let's also have a look at our output logging window on PuTTY, so we can see the connect and the notification message and the display of the temperature sensor data. And after some readings, we see the disconnection and the end of notification, and we see another notification message to start the temperature sensor data display, and then again we see the disconnect message. So today we have implemented our Bluetooth low energy service with a 128-bit custom UUID. But what's next? We can change to a standard service with a 16-bit UUID and do the implementation what's needed. And also we can have a look at the power consumption of our sensor, because it's very power hungry and that's not comfortable and compatible with Bluetooth low energy in my point of view. And sometimes in the future we can have a look at Java and Android Studio to implement our Bluetooth low energy client for our mobile device. So thanks for watching today, and thanks for going to all the hard stuff for Bluetooth low energy and the Nordic SDK number 12. And I hope you enjoyed the video and you learned something today. And if so, please subscribe to my channel and give me a thumb up. Thank you. Bye bye.